number 1 on the worksheet. Situation we're given is that we have this little weightlifter guy, and he's got a giant pumpkin over top of his head. We're given his mass, we're given the mass of the pumpkin. What we're asked to find is the force that the platform is exerting back up on his feet, which is called normal force. We haven't really talked about normal force formally yet, but I kind of gave you a clue about it yesterday. All right, this is a real specific drawing. I'm going to do a very generalized force diagram over here. So there's my weightlifter and my pumpkin. Okay? And we have two predominant, this is where I'll bust out the bright colors. We have two predominant forces acting on him. We have the F sub g, the force of gravity, on him and the pumpkin. And him and the pumpkin, remember, are a system. And we also have the normal force, which, if he is not rising up off the platform mysteriously or crashing down through it towards the center of the earth, what is true about the normal force? It's got to equal the force of gravity with the opposite sign. It's the negative of the force of gravity. Okay, now, the way that your book approaches doing these, and it's an approach I like, and it's a good setup for the problems we're going to do later, it's called sum of forces. So you've been doing the vector resolution problems from the book, and you've kind of already done this stuff, with vectors. Velocity on the x total, velocity on the y total. Okay? We're going to use that sigma notation for this, so we'll say sum of forces, and we're only dealing with the y-axis here, so we're going to do sum of forces on the y-axis. What we know is that the sum of forces on the y-axis has to be equal to the normal force minus the force of gravity. Okay. Now, thus far, we haven't labeled anything about the force of gravity on him. But what we know to be true is this. The force of gravity is equal to the mass of the pumpkin times g plus the mass of our weightlifter, what is his name, Joe, our mass of Joe times g. Here we go, Joe. So you can algebraically say it's mp plus mj quantity times gravity. Okay? And we can use that up here. Furthermore, what do we know about F sub y, sum of forces on the y? It's equal to what? 0. So what that gives us then is that Fn is equal but opposite to Fg. Okay? They're equal, they're opposite. Why is that not working?
What do you mean? That is what works.
Well, they're equal.
Gravity will be negative, so
Yeah.
Yeah. Bring it over, just gonna change
Okay. Well.
Yeah. The normal has to be negative.
Normal. Oh, it will be negative once we put it in gravity.
Okay.
Okay. So, if we go ahead and substitute this in, we now have g times, acceleration due to gravity times mass of, we'll call it g, mass of the pumpkin plus the mass of Joe. Yeah, okay. So the normal force, now the sign thing is still not working here.
Because that'll equal.
Yeah, it'll equal a negative force, and the normal force should be positive. Okay, we'll work with that in a second.
It should be negative, you're saying? The force of gravity.
The force of gravity is negative,
Normal
but normal force should be positive.
Wouldn't that equation give you a positive or negative number?
This equation will give us a negative number.
Or, no, not right. Oh, wait, hold on.
No, shouldn't the first...
They're both negative. Wait, MP and MJ are negative, right? Because the weight's going down.
No, this is
maybe the
mass.
first one's going to be plus. Fn plus.
Yeah.
No, because, oh yeah, it would be. It would be, sorry. My apologies. Yeah, plus force of gravity. My apologies. I'm rusty on these.
Negative G.
I took chapter 4 off last year. Okay, so negative 9.81 meters per second squared times, what's the mass of our pumpkin? 275 kilograms, and he has a mass of 75 kilograms. Move these.
Oh, that's a lot.
Yeah. So the normal force on him is the negative of that. And we're going to get 275 plus 75 times negative 9.81. So we get the negative of negative 33.5 newtons. Normal force back on him, and we can have 2 sig figs. So it's 3,400 newtons. Yeah, that was dumb. Sum of forces. Okay. The sum of force approach is great because it allows you to not only visually look at the picture, but then most often, for now, your sum of forces is going to be 0 on whatever axis you're working with, for now. Then we'll start with moving objects and acceleration.
Oh, fantastic.
But that's not today, so let's deal with today. Okay, questions on sum of forces approach. Okay, so get through number 3, and then we'll come back and talk together about number 4. Yes, sir?
Okay, so all you have to remember is that the normal is the negative G.
It's the opposite of G. Yep.
Okay, so then you can pretty much just go from there.
Yep.
All right.
Yes, sir.
You come up with 3.
Okay, let me shut the video off and
Okay,